Now this question says, a shop sells small boxes and large boxes for storing CDs. A small box stores X CDs and a large box stores Y CDs. Ethan buys 7 small boxes. He also buys 5 large boxes. Ethan can store a total number of T CDs in these boxes. Write a formula for T in terms of X and Y. Now this leads us to what I call word problems on algebraic terms. Okay. Now we're told that the small box contains X CDs. Okay. For the small box. And then the large box contains Y CDs for the large box. Now we're told that Ethan buys 7 small boxes. Okay, that's 7X CDs for the small boxes, and 5 large boxes, that's 5Y CDs for the large boxes. Okay, and you can store a total number of T CDs in these boxes. Okay, then write a formula for T in terms of X and Y. Now this is more like trying to tell you to form an algebraic term with this. They could just give it to you in any way and tell you to form an algebraic term. Now we're told that T is equal to 7x plus 5y. Okay, because T is a total number of CDs in all these boxes. So since the total number of CDs in X boxes is 7x, and then total number of CDs in Y boxes is 5y, so T has to be 7x plus 5y. Okay, now this is basically the formula. So it could come in any way. They could bring out another one that they will ask you to formulate an algebraic term from it, and you'll be asked to actually get the correct answer. Now there's another one too that is in form of forming algebraic word problems on algebraic terms too. And this one we're told that the table shows 6 expressions. These are algebraic terms, algebraic expressions rather. Now n is a positive integer. Now from the table, write the expression whose value is always even, whose value is always a multiple of 3. And from the table, write the expression that is a factor of 4n squared minus 1. Now for each one, we're going to write down all the expressions. We have 2n minus 3, we have 3n minus 2, we have 3 into n plus 4, we have 4n plus 1, we have 4 into 3n plus 1, and we have 2n plus 1. Okay, we're told to find out the expression that the value is always even no matter what. Okay, now for you to find the one that is always even, let's look at all these algebraic terms given to us. Now it's very likely that if you have an even number, okay, for example 2 outside of a bracket, no matter the number that is put in as n, okay, it will always be even. Okay, so let's look for one that has an even number outside of the bracket. Now to do that, we'll find out that it's just 4 into 3n plus 1 that has an even number outside of the bracket. So no matter what you put here, the answer will always be even because it's being multiplied by 4, and 4 is a multiple of 4, and 4 is an even number. So this is the answer for always even. And now we're asked for the one that will always be a multiple of 3. So we'll just look for the one that has 3 outside of the bracket, and that's this one. So this one will always be a multiple of 3. Multiple of 3. Now for the last one, we are asked from the table to find the expression that has a factor of 4n squared minus 1. 4n squared minus 1. Now to find out the factors, we just have to factorize this as it makes it easier. Now factorizing this is 2 squared n squared minus 1 minus 1 squared. 1 is same as 1 squared. Now doing this, we will find out that this is about difference of 2 squares, which we have 2n squared minus 1 squared. In which case, when we always say x squared minus a squared, which is x plus a into x minus a. Okay, using that format, we're going to do this 2n plus 1 into 2n minus 1. So we'll either look for 2n plus 1 or 2n minus 1, and that's this. So this is the answer for a factor of 4n squared minus 1. So this is how you actually look at all these algebraic terms and be able to answer word problems on them. The word problems could come in any form at all. So if you're able to look into it and look critically at them, you'll be able to answer the questions. That's it for word problems on algebraic terms.